class 6. Welcome back to the Science Digital class. Today we are starting our chapter 12 Electricity and Circuits. Chapter at a glance. Electricity, electric bulb, electric circuits, electric switch, safety precautions, cells, electrochemical cells, electric current, circuit diagram, conductors and insulators. Engage. Given below are the pictures of a few items that work on electricity. Sort these items into following two categories. Number 1, items that get their electric supply from mains electricity. Number 2, items that get electrical energy from cells or batteries. Write M for category 1, write B and B for category 2. In the present day world, it is impossible to imagine our life without electricity. It is difficult to perform many tasks if there was no electricity in our homes. We use electricity to light up our homes. We use variety of things such as fan, television, computer, refrigerator, washing machine, etc. that run on electricity. Electricity simplifies our work and makes our life comfortable. You can see all the electric appliances here. Electricity. Electricity is the flow of electrical charge or power through a conducting medium. It is one of the most useful forms of energy. It is obtained by converting primary sources of energy such as energy obtained through coal, nuclear energy, hydro energy, etc. Based on this, the power plants where electricity is generated can be classified as electricity एक electrical charge का flow है एक conducting medium से, मतलब एक ऐसे medium से जो electricity का flow allow करता है. इलेक्ट्रिसिटी को अलग अलग तरीके से ऑब्टेन किया जा सकता है, जैसे कि कोल से, न्यूक्लियर एनर्जी से, हाइड्रो एनर्जी से. और इन जनरेशन के वेज से हम इलेक्ट्रिसिटी को कुछ अलग अलग कैटेगरीज में डिवाइड कर सकते हैं, जैसे कि नंबर 1, थर्मल पावर प्लांट्स. दीज आर बेस्ड ऑन कोल, डीजल और नेचुरल गैस. Number 2, atomic power plants. These are based on nuclear fission of uranium-235 or plutonium. Number 3, hydroelectric power plants. These are based on force of water. In these plants, kinetic energy of moving water is used to generate electricity. The electricity we use at home and at our shops comes from power stations. Electric torch. During the power failure at night, the electric torch help us the most. When its switch is pressed, its bulb starts glowing, which helps us to see and locate things. But what is the source of electricity in the torch? To know this, let us perform the below activity. Activity. To examine the electric torch and find out the source of electricity in it. Materials required: torch with cells. Method. Take a torch and open its screw cap. Look what is there inside it. It has battery cells inside it. Take these out. There may be 2 or 3 or 4 cells inside depending upon the battery size. Put the screw cap back on the body of the torch. Press the switch. Does the bulb glow? No. Put the cells inside the torch and replace the screw cap. Switch on the torch. Does the bulb glow? Yes, the bulbs glow. Conclusion. The battery cells supply the required electricity to the bulb. Cells. Electrochemical cells. All cells are source of electric current. Basically, cells are of two kinds: primary cells and secondary cells. In primary cells, the chemical changes that take place are irreversible and the chemical changes are used up as current is drawn from them. Dry cells are examples of primary cells. We use a primary cell to work a torch bulb. In secondary cells, the chemical changes that take place are reversible. Once used up, a secondary cell can be recharged and used again since its chemical is reusable. Batteries or storage cells are examples of secondary cells. We use a battery to run cars. Let us know the basic feature of dry cells and batteries. Dry cell. A cell is the most basic source of electricity in a cell. There are certain chemical reactions that take place to produce electricity. The most commonly used cell is the dry cell, that is used in torches, lamps, radios, etc. The dry cell is also known as a primary cell and cannot be recharged. A cell has two terminals, a positive terminal and a negative terminal. A small metal cap at one end of the cell is the positive terminal and a metal disc at the other end is the negative terminal. Due to the chemical reaction, current starts flowing from the positive terminal to the negative terminal. There are several sizes of dry cells, but all of them produce the same voltage of electricity, which is 1.5 volts. If a higher voltage is required, several cells can be joined together in series. Another type of dry cell resembles a button that is used in small electronic devices such as wristwatches and calculators. Small in size and light in weight, no fear of leakage, spillage, can be easily transported from one place to another. Battery. A battery is the combination of cells in such a way that the positive terminal of one cell is in contact with the negative terminal of the other. A battery is used to generate more voltage because a single dry cell can generate a voltage of just 1.5 volt. The advantage of a secondary cell over a primary cell is that a discharged secondary cell can be reached by passing electric current through it, which is not possible in a primary cell. Also, the strength of the current cell produced by secondary cell is much higher than that produced by a primary cell. Electric bulb. Bulb is an electrical device used for lighting using electric current. Most of the bulbs are based on the use of filament. To study the components of an electric bulb, perform the following activity. Activity. To study the structure of a torch, bulb or electric bulb. Materials required: a torch bulb. Method: take out the bulb from torch you may otherwise one from any electrical shop. Observe the bulb from outside and also from inside with a magnifying glass. List the various parts you could see. Observations. The torch bulb consists of the following parts: metal casing having grooves in the lower parts, a small spiral of thin wire, this is called filament, two slightly thicker wires. The upper ends of these wires support the filament. The lower end of one of the thick wires is connected to the metal casing and that of the other wire to the metal tip at the bottom of the bulb. The metal up and the metal casing are fixed in such a way that they do not touch each other. This is done by using an insulation between the two. Electric current. Electric current is defined as the flow of electrical charge through a conductor. A negative charge or electrons that flow through a conducting material such as metal wire are known as electrical charge. The electric current flows from end of the cell marked plus, called the positive terminal, through the metal wires to the end marked minus, called the negative terminal. An electric current has electrical energy. This electrical energy gets converted into light and heat energy when the current flows through an electric bulb. Flow of electric current. The basic conditions that are required for an electric current to flow are as follows. A device to produce an electric current like cell, battery or a plug point acting as a source. Knowledge basket. Electric torch was invented by Konrad Hubert, a Russian-born inventor in 1902. A conducting wire made up of metal such as copper or aluminium which allows electricity current to flow through it easily. An unbroken loop of the wire running from one terminal to another terminal of the source through various appliances. Electric circuits. The path formed by the interconnection of electrical components through which electric current flows from the positive terminal to the negative terminal of the cell is called an electric circuit. For example, a bulb glows only when the positive terminal and the negative terminal of an electric cell are connected to the two terminals of the bulb. If the wires from the bulb are connected to the same terminal, either positive or negative, then the bulb does not glow. Now let's look for the activity. To study the flow of electric current. Materials required: electric cells, 4 connecting wires, a torch bulb. Method: connections have to be made between the metal wires. Therefore, remove the plastic coating from both ends of the 4 connecting wires. Connect one end each of 2 wires to the 2 terminals of the electric cell. Use tickling tape to secure them in position. Connect one end each of the 2 wires to the 2 terminals of the bulb. Secure them ticking tape. Now connect the wires in different ways as shown in figure. Observations. Bulb does not glow when connections are made according to diagram A, B, C and D. It only glows when connections are made according to E and F. Conclusion: current flows only when connections are complete or you make an electric circuit. A simple electrical circuit consists of various elements such as a battery, a light bulb, and a switch connected using connecting wires. The wires connecting two elements provide the path for the flow of the electric current. Open circuit. When the switch is off, the circuit is broken and the current does not flow through it. Such a circuit is called an open circuit or broken circuit. Closed circuit. When the switch is on, the current is complete and the current flows through it. Such a circuit is called a closed circuit or complete circuit. In this image, you can see a open circuit and the other one is a closed circuit. Symbols of some electrical components. The components such as cells, bulbs, wires, switches, etc. are called components of an electric circuit. Each component of an electric circuit can be described by its symbol. Circuit diagram. A diagram which shows the arrangement of the various components of electric circuit with the help of their symbols is called circuit diagram. इस इमेज में आप एक सर्किट डायग्राम को देख सकते हो. Electric switch. Switch is a device that makes or breaks a circuit. The on-off mechanism in any electric circuit is controlled by a switch. When the switch is on position, the circuit is closed and the current flows through the circuit. When the switch is in off position, the circuit is open and the current does not flow through the circuit. इस डायग्राम में आप एक स्विच को देख सकते हैं. Next is conductors and insulators. The material that allow electric circuit to pass through them are called conductors of electricity. Metals are good conductors of electricity. Electric wires are made up of copper because it is good conductor of electricity. Among non-metals, only graphite, pencil lead is made of graphite, is a good conductor of electricity. The materials that do not allow electric current to pass through them are called insulators. Rubber, plastic, wood and glass are all insulators. Electricians wear rubber gloves while working with electricity because rubber is a good insulator and protects them from electric shocks. Rubber and plastics are used for covering electrical wires, plug tops, switches and other parts of electrical appliances that people might touch. Switches, electrical plugs and sockets are made up of insulators. In this table, you can see various electrical components and their symbols. Safety precautions. It is said that every invention has its pros and cons. Electricity, in spite of being so useful to human beings, is extremely dangerous in nature if not handled properly. There are some very popular warnings to avoid electric shocks while using electric appliances. These are: do not put your fingers in an electrical socket. Never stick a utensil in a toaster that is plugged in. Always repair worn wires. Besides these warnings, here are some important rules to be followed to use electricity safely. First, let's check the knowledge basket. Pure water is not a conductor, but some materials, if present in water, make it a conductor. Therefore, we should not touch any electrical appliance when our hands are wet or when we are bathing. Never handle appliances when your hands are wet or when you are standing in water. Water is a fairly good conductor of electricity. If you are wet, you may unknowingly become an alternate path for the flow of electricity. Never run wires under carpet. Breaks or frays in the wires will not be easily noticed. These breaks usually cause shortcuts. It can be dangerous because the electricity flowing through the break can cause shocks or fire. Never overload a circuit by connecting too many appliances to it. Each electric circuit is designed to carry a certain amount of electricity safely. Overloading can cause a short circuit and a fire. Moral learned. Saving electricity can reduce greenhouse gas emissions, pollution, and ultimately help to saving the planet. Using less electricity also helps conserve non-renewable fuel reserves so that they can last longer. It also helps preserve ecosystem from being disrupted and damaged by extraction. Recapitulation. Electricity is the flow of electric charge or power through a conducting medium. Electric cell or battery is used to produce electric current. Bulb is an electrical device used for lighting using electric current. The complete path from one terminal of an electric cell through the bulb and back to the terminal of the electric cell is called electric circuit. A diagram which shows the arrangement of various components of electric circuit with the help of their symbols is called circuit diagram. Thank you class. Let's meet again in the next chapter.